Hello, it's me Saral, and in this video I'm going to showcase you about the countdown timer project that I made for the SIT 111 computer systems. And this is the circuit for the project. And so first of all, let's talk about how this project or the system can be a help in the real life scenario. So in our day-to-day life, we need timer. We need a time to keep our daily activities in time. For example, we need timer for reading, studying, cooking, or doing some exercise or running around. So time is really helpful or is really necessary in our day-to-day life. So how this system works is we send a command through the Linux system with a certain seconds or time, and this system starts the timer from that seconds. So after the timer is up, the system will sound an alarm or a buzzer and also blink the LED at the same time. So this system can be very helpful for differently able people who cannot see or who cannot hear. So how can we use is we need the Linux system for sending the commands or the serial monitor where we can send this how much second we need to start the timer. And so let's talk about what are the components we need for this system. So first of all, we need the Arduino board, which is the main component and the necessity which controls all the logic and the operation for the circuit or the system. So after that, we need a LCD display which displays the timer or, or the countdown in the screen so that we can look at how much time is left. And we need a potentiometer which is required to adjust the voltage or the current in the system. So after that we need a, LED bulb and a buzzer. So two resistors are also used to project the components. We other than that we need some few jumper wires to connect everything. So those are the components we need. Now let's see how this system acts in action. So let's start the simulation, and the simulation is started. We can see that LCD screen is showing up, and if we move around the potentiometer we can see the voltage drop as well. So it's okay for that. Now let's look at the serial monitor. Now if I type in start and 5, which is supposed to be 5 seconds, and when I hit enter, it starts the timer and goes up to 0 and says timer's up. Now let's see what happens when I put start and 30 seconds. Timer's going for 30 seconds, right? Now let's type in reset. See, the timer's reset and it's back to normal. So I can start another seconds. Yep. So that's how it works. So it's basically sending a command to the system, and the system takes in the timer, and the timer runs for a certain seconds, and when the timer is up, the buzzer sounds, the LED lights up as well. So let's see, now let's see what's happening behind the code. Let me stop the timer for a second, and now let's look at the code. So we're first assigning the LCD screen to various pins as here is shown over here. After that we are assigning buzzer pin for the pin number 2, LED pin for the pin number 3, buzzer frequency for the, and we are assigning buzzer frequency at 800 because this is the frequency that we want for the buzzer to be. And so behind the code I'm using the mill is function that takes the value from the Arduino for how long it's been working. So that's how the timer is being calculated in the code. So first we have the remaining time as 0 and the timer is running is false as well. So when the setup for the setup, it prints waiting for and start command and buzzer pin output. So it's assigning buzzer pin as an output and LED pin as an output as well. And so we have the serial begin 9600. So what this does is starts the serial communication, or the communication between the computer and the Arduino board at 9600 communication channel. So we can send the command from through the serial monitor to the Arduino board, or through the Linux system and to the Arduino board. So let's look at the loop. So it's calling the function serial handle, which is the function here, and it takes if the serial is available. So if the monitor is available, so it is reading the input from the user, and if it starts with the start, it will trim out the uh, number behind the string start, and it will take the seconds into the start timer, and timer is going to start after the start timer is called. So over here we have the remaining seconds as the remaining time as the seconds, and it will show up the timer in the screen using the millis function, and it will also uh, beep the LED and flash beep the buzzer and the flash the LED as well using the digital write and the tone function. So it's first uh, in the higher output, and with the delay in between, the buzzer will turn off and the LED will turn off. So it's like a blink at first. So after its call, it will go to the update timer from over here. If the timer is running, so we have set the timer to the true. After this, start timer is on. So in the update timer, it will update the timer in or it will count down the timer with the decreasing remaining time. So it's basically printing out everything in the LCD screen. So uh, when the timer is running, it beeps out. It beeps the buzzer and also blinks the LED so that we can look or observe when the timer is running or not. So the user also can know when it is going to end as well. So LED is low and LED is high. So LED high and low, which blinks. So if the timer after it's running and it goes to 0 after the remaining time is at 0. So after completing the loop, and when the remaining time reaches to 0, this condition becomes true and timer's running will be false. So it will set the cursor to the LCD screen saying that the timer is up, and it will turn up the LED bulb and beep the buzzer. So uh, it's beeping to alert the user as well. So that's the whole concept of this code. Now let's see how the circuit functions when using through the Linux system. Now I am in the Linux system. Now let's look at how we can communicate with the Arduino board using the Linux system. So first let's uh, look at or identify if the Arduino is connected to our Linux system or not. So I'm using the ls USB, which lists out the all the USB connection that I have in the system. So I can see that the Arduino SA or the Arduino SA Uno board is connected. So now let's see which serial port it is using. So I'm using the DMMSE and taking out the TTY from that. So I can see that the Arduino board is connected to the USB ACM, which is TTY ACM 0, and I can use that to interact with the Arduino board. So for interacting with the Arduino board in the Linux system or the command line, we can use application or a program that is called Minicom. So Minicom is basically a communication program that can send uh, data or informations through certain communication channel to a hardware device or something to receive that communication. So for this video I'm using the Minicom. We can also use a program called Screen, or as well we can use a Picocom as well. So uh, everything's kind of similar, but in this video I will be using Minicom. So I'm using the tag B and 9600 here because earlier in this video I uh, told about the serial and begin command, where I specify the value as 9600 as well. So what it does is, so basically it opens up a communication channel for the other systems to interact with it. So it can receive the data or information through 9600, and I'm specifying tag D, which stands for the device, and the device is my TTYCACMO0. So uh, that's how the communication is established using the Minicom. So first, if I put something uh, in the interface, I cannot see. So first, I would be configuring to uh, echo out everything that I see over here using the menu. So I'll be using the configure and screen and local echo on. Yes, I can now see that if I touch something over here. So now let's start the timer using the start and 5. So it starts the timer for 5 seconds in my hardware. So if I start for like 10 seconds, it will start for the timer for 10 seconds, and if I reset in middle, it will reset the timer. I can start as well like for 200 seconds, and it will start the timer for 200 seconds, and I can reset the timer in middle as well. So to uh, disconnect the connection, I do is Alt A and Z. It will open up the menu, and I can do is Q to quit the connection with no reset. Hit enter and I'm out. So that's basically how I can establish the connection and disconnect the connection with the Arduino board. So that's all there is to it to connect the Arduino board with the Linux system, and that's all for this video. Thank you so much.